So the schedule for this week, pushing the test back to Friday. Initially I thought that we wanted to flip these 2 days, but I think we have enough days where we can start chapter 7 next week, Monday. So we'll have today and tomorrow to do full days of test review and then Friday test. I'll have 2 help sessions tomorrow morning at 7:30. I'll go over the morning review worksheet 3 that's in your packet, and then I'll do worksheet 4 from the packet Friday morning. Okay. Okay. So also you guys picked up the test topic sheets, which I also have on my website. Just again, want to kind of go through what to expect on the test. So page 22 in your packet, you have the formula sheet for you to work off of to know what to memorize. Solving differential equations, general and particular equations. We've been working through that before the break. Tangent equation, linear approximation, creating slope field. We did all that last Friday. Slope field with differential equations, multiple choice. We'll practice a few more of those from the other packet. We'll also do one of these in class, CE to the KT word problem, where you're not really doing any calculus because you know that y prime equals ky will produce this equation. And then you're just creating 3 order pairs and then solving for C, solving for K, and then finding your approximation for the last value. Inverse trig integrals, knowing when to apply those U substitution problems, and also problems that involve completing the square. And then reviewing the quiz topics, which I'll go over towards the end of the class. Okay. Any questions about test? And then calculator allowed. You'll get to use your calculator on Friday. Okay, so let's go to page 3 in your packet. Yeah.
Wait, what's your name? Did we get supposed to do?
That was from last Friday. Where are you?
Oh, wait, if that's FRP thing, yeah, I think I got it. And you wrote it. Got it. Have you guys seen the material?
Yeah, Thursday was the inverse trig integrals. Yeah. Okay, so all this being pumped. Okay, oil is being pumped continuously from a certain oil well at a rate proportional to the amount of oil left in the well. That is dy over dt equals ky. So that's basically y prime equals ky. Where y is the amount of oil left in the well at any time t. Initially, there were 1 million gallons of oil in the well, and 6 years later, there were 500,000 remaining. Write an equation for the amount of oil remaining in the well at any time. Well, we know that this is going to follow that formula. Y prime equals ky will turn into y equals c to the kt. So we don't have to go through all those steps. So we'll just fill that in for part A. We know the process between these two is separating the variables, taking the antiderivative, solving for y. But this is the common one that we know. We'll just turn into this y to c to the k c. But this is the general equation. We also want to write the specific equation. So we're going to gather some order pairs. We know that time is going to be our independent variable. And then the amount of oil left, which is T followed by Y. So we're always going to try to create 3 order pairs here. Initially, there were 1 million gallons of oil in the well. So what order pair can we create out of that? Yeah, initially, so that's starting time. We like to let the starting time be 0. That makes it the easiest. So that at time 0, 1 million gallons. Yeah. 6 years later, 500,000 remains. Okay, so this is one of those problems that are more traditional where you know that this information is going to help you get to the C. This information will help you get to the K. And then we're going to create our equation for part A based off of this. And then finally, it says at what rate is the amount of oil decreasing when there are 600,000 gallons of oil remaining. So ultimately, we're trying to find how long it takes. Oh, I'm sorry, my bad. This is yeah, eventually we're going to do this, but that's not for part B. Okay, so we'll just try to figure out A first. There it is. Okay. All right. Okay, so the 0, 1 million, you can just fill this in for C, but we can also plug in and convince ourselves that this is going to be the C value. We know we can replace Y with 1 million. Replace T with 0. E to the 0 is just 1, so that disappears. C does turn out to be 1 million. Update your equation. Okay, so we have this taken care of. We can move on to the next order pair, which will help us solve for K. So 6 goes in for T. 500,000 goes in for Y. Eventually, I want to solve for K, but we want to move things away from this side one piece at a time. What's the easiest thing to move first? Yeah, so divide by million. Comes out to be what on the left side? Yeah, 1/2. So that's nice. 0.5. Okay, I want to solve for K. What can I do to both sides to allow for this K to come down natural log? Bring down the 6K down. Natural log of E becomes, we know that's just equal to 1. To solve for K, I can do what? Divide by 6. So there's my K value. I want to leave my K value as exact as possible. All right, so now I can write my specific equation. Okay, so that's part A. This is my specific equation. Okay, so at what rate? So we're looking for a rate, which is this formula right here. So at what rate is the amount of oil decreasing when there are 600,000 gallons of oil remaining? So for part B, we're just relying on this formula, dy dt equals ky. Because if y is the amount of oil in the well, then we know that dy dt is the rate at which the oil is decreasing or changing. So to solve for dy dt, I can just plug in k that I found and plug in the y of 600,000 and no, and by the way, you guys have the keys for all the worksheets that we're doing here. So we know that the amount of oil in the well is decreasing at a rate of negative 69,000 gallons per year. In part C, part C says it will no longer be profitable to pump oil when there are fewer than 50,000 gallons remaining. In order not to lose money at what time t should oil no longer be pumped from the well. Okay, so we can just find that third order pair there, right? We know we have our equation. Third order pair is we want to find out at what time will 50,000 remain. So I can plug 50,000 in for y, solve for t, and use this specific equation to help me make further predictions. Divide both sides by what first? $50,000 divided by a million, that comes out to be 0.05. I want to solve for t, but t is stuck inside this exponent, so what can I do first? Natural log, which will allow that exponent to freely come down. Natural log of b goes away. I can just divide both sides by this fraction. Natural log 0.05 divided by natural log 0.5 divided by 6. Let's do a slope field for number 2. On the axis below, sketch a slope field for the given differential equation at the 15 points indicated. So really, you're just taking these order pairs that you find, inserting them into the differential equation, and you're either doing one of 4 things. You're either putting a positive slope, a negative slope, a slope 0, or if it's undefined, you'll have leave that empty. But will there be any places where slope is undefined here? And what's a giveaway that there will be slope undefined? Yeah, if there's a denominator variable, right? If there's no denominator variable, usually that means there's no slope undefined. Okay. Okay, for part B, it says, while the slope field is in part A is drawn at only 15 points, it is defined at every point in the xy plane, which is true. We know that there's no places where the slope is undefined. Describe all points in the xy plane for which slopes are negative. So even though we don't see the full slope field in front of us, we should be able to look at this and as well as the differential equation and give a overall description as to what general observation can we make as to when will or what part of the graph will the slopes be negative. So if we look at this equation here, we know the x squared has nothing to say about negatives, right? Because x, this whatever is we put in for x is always positive. So the only thing that's going to cause this derivative to be negative is the which variable? The y variable. So whenever y is what? Less than 1. Yeah, less than 1, and the x doesn't equal to 0, right? Because when x is 0, that's going to force it all to be 0. But when x is non-zero and y is less than 1, we know that it's going to start producing negatives, right? So anything below this y equals 1 is all negatives except when you're on the y-axis. Okay, part C, we're going to, it says find the particular solution given the differential equation. So we're going to use this, right? Separate variables, go through all of our calculus stuff. Now, this is different than part D, which is saying find the equation of the line tangent to the graph. So this is where we find the order pair, we find the slope, and we do point slope form, right? So I want to make sure that we are clear that these are very distinct process, right? This is finding the actual solution. This is just finding an equation of the tangent line at the point. Okay, so let's go through the steps for C here. I separate, I got the dy dx's lined up in the right places. What's out of place? Yeah, so we want the y's on the left, x's on the right. So the only thing out of place is y minus 1. We'll divide both sides by y minus 1. Okay, let's look ahead here. This is just going to be how do we start this process here? Use substitution, use the denominator, but this will end up being what rule? Yeah, 1 over u du natural log. Okay, and the right side, we're just going to use what? Power rule. Yeah. All right, I would like to get this closer towards solving for y, so I'll raise both sides. E is the base. Set up here. Separate the c away from variable. Notice your change in operation here, plus in the exponent. For instance, a multiplication. This becomes multiplication. Drop the absolute value. So this feels like an easy place now for me to solve for c. Okay, 0 in for x, 3 in for y. E to the 0 is 1. So 3 equals c plus 1. Subtract 1 from both sides, c equals 2. Okay, we know we're doing something different for part D because it says find the equation, not of the differential equation, but of the tangent line. So tangent line is linear. So we know it has to be this form, right? Okay, so that means we need to find order pair, we need to find slope. Okay, what's available for us to find slope? Derivative, yeah, our differential equation, right? So the fancy word for slope. Take your order pair, plug in, find your slope. Okay, so this doesn't end up being as interesting because that zero slope is going to basically turn this into a really simplistic equation. Okay, but normally the next part, it says use it to approximate f of 0.1. So normally we'll do what after this? Yeah, 0.1 in for what? In for the x, right? In this case, that zero is just going to wipe everything out where it's just not going to be as interesting. Your answers will be the same. So my equation is y equals 3. But after the approximation is still equal to 3 because it's just a horizontal line. But usually it's going to be a different value, right? So are we comfortable with this process here? Tangent line equation, order pair, slope from the derivative, tangent line equation, and then your linear approximation is where you just take that additional step, put that decimal into your linear equation, and then get that decimal value. In this case, it's not decimal value, but normally your slope is not 0. Okay, I'm going to skip down to the use substitution problems. So page 4, number 4. Okay, so what gives it away that this is not just going to be a normal use substitution problem where I set the u value to be 1 minus x to the 6th? Yeah, degree, there's a big gap, right? This will be a better fit for normal use substitution if this is 1 minus x to the 3rd power, because then we know that 3x squared will handle that nicely. But that large of a gap, we know there's going to be some sort of a arc trig involved. Rule that we're going to target, we know it's not the arc tangent. Because arctangent has no square root. It's either arcsecant or arcsine. Arcsine is the one where your variable comes second and your constant comes first. So here's the rule we're going to try to attack or apply here. Arcsine is the only one without the 1 over a in front. And it's always u over a inside the parentheses. Right, so the first thing that we do, once we recognize the need for arc trig, we're always looking to get the denominator to be in a better form, right? We'll produce those parentheses with the squared outside so that we're picking out the correct a and the u value. Okay, so our first step is to figure out what can I put inside the parentheses, but still maintain my starting value or my starting denominator. So here, any changes? 1 squared is the same thing as 1, so now what can I put inside the parentheses so that when I square it, it ends up being x to the 6th? So third, right? Exponents next to each other, we multiply them. So 3 times 2 is 6. So now this gives us a big help because we know what our a value is. Our a is always the constant, and our u value is always the variable in it. So we're going to make a replacement with these 3 pieces, and we're hoping to make it look exactly like this rule to convince ourselves that we can apply this antiderivative rule to get to our answer. So our u value is x cubed find the derivative. Solve for dx. Okay, we'll make our substitutions. Okay, so that derivative of 3x squared is really helpful because we know we can't move forward unless the x's find a way to disappear, and they do. But you got to keep track of what? This comes out as a what? 1/3, right? 3 in the denominators. Okay, perfect match with the rule that I want to use. Okay, now I can apply my rule. Okay, my u value is 3x squared. Sorry, x cubed. My a value is 1. You drop the 1 if you like, since that's not going to clean that up and just say arc sine of x cubed. Okay, number 5. Okay, what gives it away with the number 5 that we know what type of problem this is going to be? Yeah, what about that x squared? X squared here, but the top is what? 0. So there's a gap, right? There's a degree of 2 or more. We know it's not just a normal use substitution. It's going to be our trig. This is the one without square root. So this has to be what? Has to be arctangent. Okay. So eventually we're going to follow this rule here. Okay, but the denominator is not quite ready for us to create those parentheses. There's a process we have to go through. What's that process called to get this cleaned up a little bit more? Complete the what? Complete the slip. By complete the square, we can get the expressions to be nice and clean, parentheses squared, and then that, because right now we really can't pick out the a and u value as it stands, so we need this denominator to be in a different form. Okay, so here's how we complete the square. We'll step to the side here. Okay, you're always going to have a plus space and a minus space. And that space is going to be filled in by this formula, b over 2 squared. What's my b value? 6. 6 over 2 is 3. 3 squared is 9. So that allows us to factor this cleanly. 1 multiplies to be 9 and adds up to be -6. -3 and -3. Okay, 14 minus 9 is 5. Okay, so this cleans up to be x minus 3 quantity squared, right? So now let's go back to our original problem. I'll pull the 4 out in front. Okay, so now it's beginning to look more like what we want, right, with the parentheses, but I still want to get this to be in a set of parentheses. So if we want to put this dx out, we can. Now we know the x minus 3 is good. But what can I put inside this parentheses so that when I square it, it ends up being the same thing as 5? Root 5. Now your a and your u may be out of order, right? But we know what our a and our u value is because your u has the variable in it. The a is the constant. All right, perfect match. Now I can apply my rule. -4 first, then the a, 1 over a, then r tangent u over a plus c. 1 over a, my a value is root 5. U over a. It's okay to leave radicals in the denominator. Okay, let's do one more. We'll skip number 6 and let's try number 7. Okay, so we know that secant is one of the new trig rules, right? Involve natural log. So we know that we're going to target this rule here. But it's not just an x, right? If it was just secant of x, they can jump directly in and without doing anything. But here, this is more than an x, so we got to go through what? Use substitution. Which is the same thing as 1/2 x. Can you guys predict, because this is a coefficient of 1/2, what's going to come out of it at the very end? A 2, yeah. So it's always just the reciprocal of the derivative, especially with these easy or these linear u values. Pull the 2 out in front. So now we just follow the rule. Then replace the u back in terms of x, and then make sure we keep the 2. Okay, tomorrow, we'll continue with, worksheet 2, which is page 11. Maybe we'll practice some more with, multiple choice with the, slow fields. Okay, but tomorrow morning, I'll do morning review worksheet 3, and then Friday morning, I'll do worksheet 4. Okay? All right, come and get your phones. Oh, third.
I was. Okay, that was really nervous. Yeah, no, 9.
Yeah, that's okay. 0.
Oh, yeah.
Anything that's 0.
Oh, yeah.
The phone number.
I don't know.
Yes, yes. Page 22.
It's like, I don't I had like a lot of questions.
Okay. Thank you. Yes. So, let's say you were starting to solve the problem.
So you signed up for your bonuses for nothing?
So, you gotta go through the whole process here.
So. It's only like 8 lines. Yes. You wouldn't carry his television block. No, but I really love watching the movie.
So,
I know, but not actually read. And then you know, it's not the being like to actually.
okay, good so far.
Yeah. Yes.
So we have to go through your substitution, so that's always the first step. But just ignore the right side. Imagine you're just being the left side.
I will be like.
So if I want to solve this problem, I have to go through these steps.
I just think I shuffle just. But I didn't take the fours left. Yeah, no, like literally like.
That's fine. Yeah, you can leave the forward side.
Yeah, and then, yeah, and it's not. And it's more of you have to be like, because the 4 and the 3 are on the problem where it's switch. The 4 and you're like, if you use their chance to hold chords.
Well, you can only cancel out what is left over, so
Yeah.
there's no 4 left over. In the
Well, it says the 3. Like, early purchasing a pill. My next. Yesterday, my cooldown. My cooldown was sitting at the top of your page.
So the 4 cancel out.
Watching Justin kind of.
And then there's over.
Me and Shay went to like Starbucks.
So the integral of e to the u is e to the
And I
u,
had to stop like 4 times. It's like vomiting right now.
and then replace the u back with x.
And I was like basically just like, like the people on the road driving,
Yeah.
like I'm so out of shape. They're like so bad. Cause I'm literally like walk like.
It's okay, just what's sitting in front of.
Yeah, so.
Okay.
And then just like, y'all go like. And like. It's so sad.
Because look, it's pretty much, I know, right there, right?
Probably like me.
But except for, with this case, it's like, oh.
So basically, I'm just asking, what's the coefficient in front of my answer? That's what's my answer, that's what I'm asking for.
And then the next one asks. Really? And the next one after.
We run.
This one, rule that we learned, this one is the original,
So
Oh,
like,
this
people like volunteer, do like the 2.
kind of uniform, negative cosine.
No, I bet they would do that. We should run every event. And then.
Seek it.
I don't know if I can do that.
It's smoking in the floor. Really? No, our program works and we do the therapist.
This is just.
For senior night.
Why did this one?
What is
Okay.
No, they're gonna beat us this week.
Kurt Emerson. Oh, Calista and
like.
No, you're right. Plus he's correct. I made a mistake.
It makes sense. I don't know.
And then it's the definitely.
yeah, we're definitely gonna get
It's gonna.
And then also,
you can be in a
yeah, this one,
They can bring us off.
yes. And also, yeah, that's just the,
No,
yeah.
I don't think she's doing this year. So. And then I got this wrong stuff. I feel like she just. I don't
I think
think
Sherry's calling around.
I'm convinced it's just like a fake thing. How is that? Because if you're man, we're just one for. How about you can get some? What she's been running before there, except he's like, oh, she's so good. Yeah.
Oh,
Wait, can that apply to all the other passes?
y'all are like in the fifties,
for real?
right? 60s. If I do better in that.
Up of your phone.
Hopefully this year, 58. Like,
Okay, we're going.
but I have 0.99.
If I get a 90 on the test.
No, it's just to help students.
If they even market. Honestly, this looks like we're gonna get back. You have my sites. No, it's for the part. When you're done and you do well, he's like.
Have a great day, guys. See you tomorrow.
It's just more of like, it's a 4x4. And he doesn't want to put me in the open floor. That's my slowest. It's a like.
Thank you.
I see.
No, maybe I get.